Friends, welcome here in the new topic of Maths 2, that is Pythagoras theorem. Friends, you already know what is Pythagoras. Always this Pythagoras we have to apply in right angle triangle only. In right angle triangle, what are there? There is one angle is right angle. Its opposite side is obviously we can say it is a hypotenuse. Okay, and remaining two sides are called as sides making right angle. See here, suppose here it is one triangle which is right angle triangle. Yes, this is right angle. So we can say this is hypotenuse. Why? Because this is opposite to right angle. And these two sides are called as sides making right angle. And one more thing is very important in right angle triangle. Except right angle, remaining two angles are always complementary. Complementary means what? Their sum is always 90. Okay? This basic knowledge we have to know before starting this topic. Okay? What is the Pythagoras? Yes? Pythagoras. I think we applied from 5th, 6th, 7th standard we applied already here. When you were solving the examples. What is that? Square of hypotenuse is equal to sum of squares of remaining two sides. Means what? Suppose here it is ABC is a right angle triangle in which AC is hypotenuse and AB and BC, these two are sides making right angle. So how to apply and what we have to apply that Pythagoras? Here it is AC square. What is this? Hypotenuse square is equal to side 1 square plus side 2 square like this. Understand, friends? Okay. Now, sometimes we are going to verify whether it is right angle or not by the information of three sides are given. Suppose, see here A, B, C, here these are the three sides. Okay, in which suppose here B is the greater one than A and C here. Okay, at that time, what we have to check? B square should be square of largest side. If it is equal to sum of squares of remaining two sides like this, then we can say the triangle having these three sides are said to be right angle triangle. Okay, like this we are going to verify the given set of three numbers are said to be as the sides of triangle. It is called as Pythagorean triplet or not. How we can verify whether the given set of numbers is Pythagorean triplet or not? We'll take one example. See here, suppose here 3, 4, 5. This is a set of three numbers in which 5 is greater number. Okay, so first of all we are going to write down some letters here. Like A is equal to 3, B is equal to 4 and C is equal to 5. Here the C is the greater one. We'll write C is equal to 5, square it to both sides. What we get? C square is equal to 5 square, which is 25. Write equation number 1. And right now the remaining two sides A and B. Okay, so here A square plus B square. Okay, what is A? 3. So 3 square plus 4 square. What is here? 9 plus 16. Here it is 25. This is equation number 2. See here, from 1 and 2, what we can verify? Both are same. That means from 1 and 2, what we can write? C square is equal to A square plus B square. Hence, the given triangle is right angle triangle. Like this, we have to verify the given triangle is right angle or not. So sometimes here in the textbook, they are given to us one formula. What is that formula? See here. Suppose here A, B, C. Look here. A, B, C are some numbers here. Okay. Or we may take here only A, B. Okay. A and B are some numbers here. We are going to take here first one A square plus B square is the side 1. Then A square minus B square is second side. And here 2AB is third side. In which we have to take A must be greater than B. Like this we have to check. Okay. That means what? we cannot get the side is negative. If we take A is less than B, then here we can get the negative number. We know the side is never be negative. That is why we take as A is greater than B. So now we can put any A and B are natural numbers. Any. But remember this condition must be. Okay. Then the numbers, 3 numbers we can get, that is always Pythagorean triplet. Yes. We'll take some numbers here. Okay friends. See first. In this particular formula, we are going to put the values of A, B, then let's say which are the 3 numbers which are Pythagorean triplet. Suppose I'll take here A is equal to 3. Now don't take B is equal to more than 3. Take less than 3. I'll take here 2. What do you get here now? Here it is A square means what? 9. B square plus 4. Okay, here A square 9. Okay, and B square is 4. Okay, now here 2 into 3 2s are 6 and 2s are means what? 12. So here it is 13, this is 5 and this is 12. So hence it is a Pythagorean triplet. Understand friends? Like this we can verify so many numbers which are either Pythagorean triplet or not. Like this we can verify. Yes friends? Similarly, in 9th standard, we already know 30, 60, 90 triangle and 45, 45, 90 triangle. That also we need in this topic. Okay, let's see here. Okay, if 30, 60, 90, what is that? Suppose I draw one figure here in which one of the angle is 30. Okay, and other one is 60 and the third one if it is 90. What is there? Look here. This is the triangle in which it is 90. Okay, I'll take here it is 30 degrees and here it is 60 degrees. In 9th standard already we know. Look here, this is the 30, that means this side is said to be side opposite to 30 degrees. Okay, now here 60, this is angle. So this side should be what? Side opposite to 60. And obviously, because of this one is right angle, I'll write here this is hypotenuse. Okay, friends. See, I'll take here triangle ABC in which angle A is 60, angle C is 30, angle B is 90 degrees. Okay, and AC is what? Hypotenuse. So already we proved in last year side opposite to 30 degrees. Side opposite to 30 degrees. Who is there here? AB. So that one is always half of hypotenuse. Which is hypotenuse here? AC. Then we can write AC upon 2 like this. Yes, when it is, if the triangle must be 30, 60, 90 triangle. Understand? Similarly here, side opposite to 60 degrees. Yes, here the side is what? BC. So that BC is, look here. It is always root 3 upon 2 times of hypotenuse. Here the hypotenuse is what? AC. Like this. Understand friends? Remember all these are very important in this topic. Okay? Similarly, as like 30, 60, 90, there is one more triangle is there. Remember, one more thing is, this 30, 60, 90 triangle, when it is in your compass box, the greater, which you can say here, yes, set square is always of 30, 60, 90 triangle. Check you, okay? And again I am telling you, this side is obviously always half of this one. Try to check in that particular set square. Okay, there are 2 set squares. The second one is isosceles right angle. The 2 sides making right angle are always congruent. Okay, so that set square is called as 45, 45, 90 triangle. Okay, except right angle, remaining 2 angles are of 45 each. Okay, so in that particular triangle, means in 45, 45, 90 triangle, there is also one property, and that property is also very important. Look here, I'll draw that figure also. Look here, of 45, 45, 90 triangle. Look here first. In that particular triangle, first of all, these two sides must be same in that particular triangle. Because of these two sides are same, in last year already we know in isosceles triangles theorem. What tells us? If two sides of a triangle are congruent, then what you can write? Their opposite angles are same. So here also these two angles are same. But because of it is right angle triangle, remaining two are complementary, but they are same, means each will get here 45 degrees. Because of it is right angle, we can write this is hypotenuse. Yes? Suppose I will take here PQR is right angle triangle, in which PQ and QR both are same. This is right angle, hence these two are 45 each. Because of like this one, whenever the triangle is like this one, we can write what? Side opposite to 45 degrees. Here the two sides are same. Here this is the side which is 45 opposite, and here also, that means PQ and QR both are same. Okay, and whenever like this, then we can write it is always 1 upon root 2 times of hypotenuse. 1 upon root 2 times of hypotenuse. How it comes? It is very simple. Apply Pythagoras, put a value instead of PQ, write QR, or QR, write PQ. Finish. Try to simplify, we'll get an answer. See first. I will verify this one. See first. PR square is equal to PQ square plus QR square. Here I'll write PQ square, and here also I'll write PQ square. Why? Because PQ and QR both are same. This is PR square. Okay, write this PR square that side, twice of PQ square. So this 2 comes this side, 1 upon 2 PR square, which is PQ square. Taking square root to both sides. Here it is PQ. This is 1. Square root of 2 is what? 2, root 2, and here it is PR. Finish. That's the proof. What is PQ? This is side opposite to 45, and which is 1 upon root 2 times of hypotenuse. Like this, we can verify so many properties. That means for that we have to know the previous knowledge. It means in 9th standard, what we studied, not only 9th standard, in previous classes, what we studied, that everything, every part in mathematics, you have to remember. So anytime we have to apply some properties that should be you know. Okay friends? Now the next part also we can take by using this part. Okay friends? Friends, we can prove Pythagoras theorem by so many different ways. Okay, we'll take one of them. Look here. As you know that sides 4, 3 and 5. That triangle is right angle triangle. Yes? Look here. I'll take here that particular only. Look here, suppose this is 4, this is 3. Then definitely it will come 5 if it is right angle triangle. Okay friends? Look here. Just concentrate here. Suppose it is a 4. Okay? That means I will draw one square with side 4. That means like this one. Okay? Just try to imagine all sides are same. Okay? Similarly, here this is a side 3. So I will draw one square of side 3 each. Okay? Like this. If it is not looking like square, just try to suppose it is a square. Okay friends? Now here, this is a 5. Here also I will draw the one square with side 5. Okay? Just try to imagine. Now look here friends. This is 4, means I will make 4 parts here. Just try to concentrate. And here also I will make 4 parts. Means this is how many squares, small squares are there? 16. Okay, here also I will draw 3. Means how many squares are there? 3 square means what? 9. Now look here, here 5. Means I will take here. Just look here. Okay. Okay friends. Just try to observe here. Now tell me here, how many squares are there? 25. Just try to look here. It is very important. What is area of this one? What is area of this one? 16. What is area of this one? 9. What is area of this one? 25. Just observe here, 16 plus 9 is equal to 25. Is that okay? Okay? So, see here. What is this? This is a square. So, we know the formula of square. What is that? Side square. Means it is what? 4 square. Means area of this square. Understand? Now here, what is this? Square. We need area. Means what again? 3 square. Okay, side square. Now here, this one is equal to this one. What is that? Square with side 5 means side square. Is it okay? Why? Because of 16 plus 9 is equal to 25. Like this we can verify. So it is what? Hypotenuse. So square of hypotenuse is equal to sum of squares of remaining two sides. Like this we can verify. There is one more method is also there. Okay? That is depend upon trapezium. In that trapezium we have to know what? I'll rub this one first. See here. Trapezium. Do you know trapezium? In the trapezium, pair of one opposite side is parallel. You know that one. Okay? But I'll take just different way. Look here. What is this? This is one right angle triangle. I'll take here this is x. This is 1. Okay friends? Now, same thing, same triangle, I'll write it different way. Means what? Here I'll take this is y, like this one. Now I'll take here it is x. Okay friends? Like this. Both are same, congruent we can take here. Okay? See here. This is just like here it is. Understand? Now I'll take this is as a z. Obviously here also z. Why? Because they are the same triangles. So obviously their hypotenuse is also same. Okay? So these two are same. Now I'll just join this one. Because of these two are perpendiculars, so we can say it is what? Trapezium. Okay? Where the two sides are parallel here, these two are parallel. Yes? Now this is their height. Okay? The distance between parallel sides is called as height here. Okay? What is area of this particular trapezium? We know here area of trapezium is equal to half into sum of parallel sides into height. Yes, this is very important formula. What is that here? Half into. What is sum of parallel sides? This is y, this is x. Both these are parallel. I write here x plus y into. What about height? This is height. Again it is what? X plus y, which is height. So what will, yes, what you can write here? Half into x plus y bracket square. This is area of trapezium. So now this area of trapezium I split in 3 triangles. Okay? See first, what I am telling here. This is 90, this is 90. See in only one triangle. See here. May I write here A and B? Okay? What is this A and B? A plus B is what? 90. You remember? In right angle triangle, except the right angle, remaining two are complementary. Okay? Now, so look here. Because of this is A, we'll draw this triangle as like this one. So here it is A. This is B. Okay? What we know? A plus B is 90. So these are the 3 angles which are in linear pair. Means they're all, sum of these 3 angles is 180. But remember A plus B is what? 90. Means remaining that angle is 90. That means this triangle is right angle triangle. Okay? Means all the 3 triangles are right angle triangles. Okay? Now, sum of parallel sides. What is this? Area of trapezium. Okay? That area of trapezium is nothing but sum of 3 triangles. Area. Okay? First of all, area of this triangle. Tell me what? Half into base into height. Is it correct? Half into base into height. Okay. What about this one? Plus half into base into height. Base and height both are same here. Z, Z. Okay. Now this side. Not plus Again, half into base into height. Base and height. So that one is equal to half into x plus y square. Why? Area of sum of these three triangles is nothing but area of trapezium. Because by these three triangles only the trapezium form. Okay? So that one is equal to half into x plus y by x. Just try to what you can say here? Express here. Okay, see first here. Look here, I'll just write here half into xy plus half into z square we can write plus half into xy. That's it, I'll just expand. So half into what we can write here? X square plus 2xy plus y square. Okay. Try to just observe here. See, half xy, what you can say? 1xy. Is it correct? Right, just 1xy plus 1 upon 2 z square. Okay, and that side half into x square plus 2xy plus y square. These two, I'll just multiply to both sides by 2 because 2 here 2. Okay, just try to multiply to both sides. What you can say here? Here it is 2xy because we multiplied here. After multiplying by 2, that 2 removes here. It is z square. Here also that one 2 removes. So x square plus 2xy plus y square. If you observe these two sides, 2xy is there. So what remains here? This is nothing but z square is equal to x square plus y square. What is this z? This is nothing but the hypotenuse. Yes, which is equal to x square plus y square. Like this, we can verify Pythagoras theorem. Understand? So there are some different methods here. Here these are the two methods. But actually we have to prove in this topic by making that some step-by-step procedure. Okay friends, we'll take the next part. Yes, now we'll take the first property of this topic, which is called as similarity and right angled triangle. See here, this is very important property. Look first, I'll draw the figure here. In this particular triangle, we have to draw one altitude from the vertex of right angle to its hypotenuse. See here, like this we have to draw one altitude or perpendicular to its hypotenuse. Then the two triangles form, which are again right angle. So these two triangles are similar to original triangle and each other. This is the statement of this one. What is that? Similarity and right angle triangle. This is the property in which what? There is one right angle and the altitude drawn from vertex of right angle to its hypotenuse. Then the new two triangles form, which are obviously right angle. They are similar to original triangle and each other also. Okay, that part we have to prove. It is very important. Look here, I'll write the names here. Take the PQR is a right angle triangle. This QS is altitude drawn from vertex of right angle to its hypotenuse. So look here, I'll write first given part. What is given? In triangle PQR, angle PQR is what? 90. Okay, and QS, which is perpendicular to PR, where P dash S dash R. So what we have to prove here? We have to prove three triangles are similar. Remember here, we don't know in which one-to-one correspondence they are similar. Okay, that will comes after proof. Okay, but in some examples we have to apply this one. So this one we can write there is one technique. How to remember this technique? I'll draw here. Just see here. This is the triangle. Suppose I'll take here A, B, or this is the same thing I will take here PQR. Okay friends? PQR. In which way we have to take the names of that triangles? See first. First of all, we have to take the bigger triangle's name is in this particular direction. What is that? PQR. So I'll write here PQR. Similar to that above triangle, I'll take the name of that one in this way. That is what? PSQ. This is only the trick to remember how to take the names of the triangle without proving. Because after proving, we have to apply this property in the example now. That is why we have to know how to take the names. Okay? PSQ. And this downward triangle, so how can take the name of that one? Is nothing but like this way. That is QSR. Okay? Let's see whether it will come or not. Okay? After proving. See friends. Look here. I'll make here two pairs of triangles. See, first of all, I'll take here, this is the above triangle, the upward triangle, this is the downward triangle, and this is the bigger triangle. Okay friends, this is name of, it is what? PQS, here it is again QSR, and this is PQS, or PQR, sorry, PQR. Okay friends, now all these three triangles are here right angle triangles. Okay, so first I'll write in proof part. What is that? Given part I'll write first. Okay, in triangle PQR. What is that? Angle PQR, which is 90 degrees, and this QS is perpendicular to PR. It is everything they were given to us. Okay, so just observe here. I'll take this triangle and that above triangle. Okay, upward triangle. See, just try to observe here. This right angle, this right angle is there. Okay, now with the same time, this is the angle which is common in both the triangles. Means by AA test, we can prove these two triangles are similar. Very simple it is. So first I'll take here in triangle PQR and triangle, this is triangle. So before proving the two triangles are similar, take by any one-to-one correspondence. But when you are writing similar, at that time you have to write in one-to-one correspondence only. So I'll write here, okay, here PSQ will come, but I'll just make some change the name of it. I'll write here PQS. Okay, you can write PSQ, but without doing, you don't know how can take that one-to-one correspondence. Take anything like PQS. See first here. I'll write angle P to angle P, which is common angle, which is, yes, see here, we can write by one letter, okay, no problem. This is common angle. Okay friends. Now one more angle, which is right angle. Here it is. Angle PQR, always take, when you will take that name of first triangle now, so here the first element should be of the same triangle. This is one discipline in this geometry. So take first PQR, which is congruent to here, 90 is what? PSQ. Okay, this is, tell me, from 1 and each 90 we can write here. Okay, now, the two triangles becomes now similar. Write the PQR as it is. You have to check the name of that second one very carefully. See first, P to P means what? Here it is P to P, no. Where it is? Here the first P means we have to write here only the P. Okay, afterwards, this Q to S, where it is Q? Middle one. So we'll write here S. Okay, remaining the place is there of third vertex, here it is of Q. Like this we can get here PSQ. Understand friends? This is the way. This is by a test. Very similar in triangle PQR. And this downward triangle, that will come QSR. I'll just check, take any different way. Yes, RQ, SRQ, okay? You can take RQS, anything, but you will get definitely QSR. Okay, so here again in this one particular, this is the R, which is common angle. Okay, so angle R to R we can write common angle. One more angle which is obviously of right angle. So write angle PQR congruent to angle QSR. This is again from 1 and each 90. See, in this way the two triangle becomes now similar. Write the first one PQR as it is. Again we have to write one-to-one correspondence. R to R. Okay, where it is R? Last. So write R last. And about Q to S. So where it is Q? Middle. Write S middle. See here, S and R both are okay. Now just remaining Q, just write where the place is there. This is QSR. Understand? Like this. This is the AA test. And once the two triangles pair, in fourth one and seventh one they are similar. Right now by transitivity we can get all the three triangles are similar. So triangle PQR similar to triangle PSQ similar to triangle QSR. This is from fourth step and seventh step. Understand friends? This is very important part. So many times we have to apply this one directly as three triangles are similar. When? If the triangle is right angle and there is one altitude drawn from vertex of right angle to its hypotenuse, then straight away we are going to write the three triangles are similar by using which trick? This is the trick to remember how to take the names. Okay friends? Friends, take the second property. Okay, that is called as theorem of geometric mean. Geometric mean you studied in last year Maths 1. What is the geometric mean? Yes, suppose three terms are in CP. What is the CP? Continued proportion. Then the middle one is called as geometric mean of extremes. So we have to apply the same thing here. But algebra, how to apply in geometry? So both are very similar. So many times geometry we have to apply in algebra and algebra we have to apply in geometry. That means both should we have to know here. See how? In geometric mean theorem, what tells us? First I will say here statement. In right angle triangle, okay, perpendicular segment drawn from vertex of right angle to hypotenuse. Then that perpendicular segment is the geometric mean of two parts of hypotenuse. Because of that perpendicular, the hypotenuse is divided in two parts. So that perpendicular segment is geometric mean of the two parts of hypotenuse. Okay? So geometric mean means what? It is the square of that segment is equal to product of two parts of hypotenuse. That one we have to prove. See, I'll draw the figure. Okay, this is the right angle triangle. Yes, you can give any names, no problem. Either PQR, ABC, EFG, anything you can take. LMN. I write now LMN. Chalo. Okay, LMN. Like this. Okay, now given, what is it given? In triangle LMN, that is right angle, no? Means angle LMN equal to 90. There is one perpendicular drawn. So write here P. So what? MP perpendicular to LN. Where the P? This is L dash, P dash, N. So whenever like this one, then what we have to prove here? We have to prove, look here, this MP which is a perpendicular segment. This is geometric mean of two parts of hypotenuse which is LP and P here. So geometric mean means what? Square of MP. Okay, square of MP is equal to product of these two, LP into PN. This one we have to prove. Okay, very simple. Here also we have to apply the property what we proved just previously. Whenever the triangle is right angle triangle means one of the angle is 90, there is one perpendicular drawn on hypotenuse from the vertex of right angle, then all the three triangles are similar. Which property? Similarity and right angle triangle. By that property we can say all the three triangles are similar. Okay, first of all, I will write here in the proof part. Friends, very carefully, whenever you have to apply some property, mention that by which property it will come. Okay, see first. In triangle, which one? LMN. Okay, angle LMN is equal to 90. Here MP, which is perpendicular to LN. This is given part. Okay. Now, straight away I will write all the three triangles are similar. You know how to write the names of the triangle, that trick. Just try to remember that one. See first, bigger one, LMN. By this way, I'll draw that one direction like this. Okay, the upper one is like this one and the lower one like this one. Just remember this is not mentioned in textbook. It is only our trick to remember how to take the names with one-to-one correspondence. Every time no need to prove that one, right, directly, because we already studied that one. So take LMN similar to this LPM, similar to MPN. Okay, this is, we can say, from 1, and similarity and right angled triangle. Okay, mention by which property that one. Now see here, what we need? MP square. Means what? We need MP. Definitely we need MP only first. So where it is MP is there? In this triangle there is no MP. Means I'll take these two triangles in which MP should be there. So write first. Therefore, LPM similar to MPN. This is from 2, second step. Now their sides are in proportion. Whenever the two triangles are similar, we can take their corresponding sides are in proportion. So write LP upon MP is equal to PM upon PN. See here, first two, last two, last two. Take first, last, first. Like this is a one-to-one correspondence. We write LM upon MN. This is corresponding sides of similar triangles. Now look here. We need MP only. Here it is the MP. That means this particular one, no need. We can write, but no need to take. Now just look here. Just go with cross multiplication. What will we see here? MP, PM, both the same. What we need? MP. So write MP square. Am I right? MP square. Go with cross. What you can write? LP into PN. Yes, this is from 4. Look, this is the proof of this particular thing. How simple it is. Look here. Just but very carefully apply the properties what we studied in previously. Okay, friends? Now, friends, Theorem of Pythagoras. Previously, we'll take some different methods, but now we are going to take which is the method the board mentioned. Okay, we'll take that one. Pythagoras theorem. What is Pythagoras statement? What we can write here? If in a right angle triangle, square of hypotenuse is equal to sum of squares of remaining two sides. That one we have to prove. If it is right angle triangle, then square of hypotenuse which is equal to sum of squares of remaining two sides. That one we are going to prove. It is depend upon previously proved properties. Okay, see here. I'll draw first figure. This is again a right angle triangle. I'll take the name of the triangle like PQR. Okay. Okay. See first. Given in triangle PQR, angle PQR is equal to 90. This is only given to us. So from this we have to prove square of hypotenuse means PR square, which is equal to PQ square, one side square, plus second side square. This is we have to prove. Okay. Now, only by this much only, We cannot prove. We have to apply some properties which we proved just previously. In both the properties, there is one altitude drawn from vertex to right angle. So here in construction, we are going to make that one. So in construction, what is that? Draw. It is construction. So draw by dotted line. Draw what? QS, which is perpendicular to PR such that P dash S dash R. Okay friends, this is very important. Because of this, now we can apply both the properties. But apply what we need. That only property we have to apply. See here, PR square, PQ square, QR square. What is these are? PR square means PR into PR. When we get PR, if there is in first ratio in numerator, if in second ratio, if it is in that PR in denominator, and they are equal, then by go with cross multiplication, we'll get PR square. Okay, this ratio, when it comes, if two triangles are similar, then sides are in proportion. Means what? Look here, we need PR square. So obviously we know here how many triangles are there? There are 3 triangles. Now we have to choose out of these 3 triangles, 2 triangles in which PR should be there. Because of PR. Okay, sorry. We'll take first PQ. We'll take first PQ triangles. Okay, tell me now, where the 2 triangles in which PQ is there? See here, in bigger one and in this top triangle. Both are similar. Yes? So, their sides are in proportion. Go with cross, we'll get PQ square. Finish. Very similarly, we need now QR square. So, we have to choose the 2 triangles in which QR is there. See here, that bigger triangle QR is there and this lower triangle also QR is there. So, again they are similar because we know it. What is that? Similarity and right angle triangle. By that property, they have become similar. So, their sides are also in proportion. Go with cross multiplication, we get PQ square, QR square. By adding these 2 and by simplifying, we will get definitely PR square. Okay? But before that one, we have to apply that property, similarity and right angle triangle. So to use that property, what we need? The triangle must be right angle and there is one perpendicular drawn on hypotenuse. And both are is there in given and in construction. So both will write here, in triangle PQR, angle PQR is 90. Okay? And QS is perpendicular to PR. This is given and construction. Okay friends? Now, because of these 2, I'll write all the 3 triangles are similar. As we know that trick. Yes? PQR. Okay? PSQ and QSR. This is a trick to remember. Okay? To write PQR similar to PSQ similar to QSR. Okay? This is from 1 and you can write here similarity and right angled triangle like this one. Okay? Now, we are going to choose the 2 triangles in which PQ is there. Where the PQ is there? Here PQ and here also PQ. So, we'll take first 2 triangles. Triangle PQR similar to triangle PSQ. This is from 2. Their sides are in proportion. PQ upon PS, QR upon SQ and PR upon PQ. This is from corresponding sides of similar triangles. See here, PQ and PQ is there. So, don't need, take to middle one. So, go with cross multiplication. What will get? PQ square is equal to PS into PR. This is from 4. Keep this one as it is. Again, I will take here, we need what? QR. Where QR is there? Here, QR. And here it is QR. Yes friends, means first and third triangle I will take here. And triangle PQR similar to triangle QSR. This is again from 2. Their sides are also in proportion. Take that one. So PQ upon QS. QR upon SR, PR upon QR. This is corresponding sides of similar triangles. Look here, what we need? We need only QR. So here these are the QR. So the first one, no need to take. Again go with cross multiplication. What will get? QR square is equal to SR into PR. This is from sath. Okay, this is not the finish of this proof. Look here. So we need their sum. Means the fifth one and eighth one we are going to add them. Okay, see here by adding 5 and 8. Look here. This is the ninth one. What you can write here? PQ square plus QR square. Is it correct? Yes. PQ square plus QR square. This side is what? PS into PR plus what is next? SR into PR. Okay, I'll write in neat form. Look here. What is that? PS into PR plus SR into PR. Okay, by adding 5 and 8. Okay, now I'll keep this one as it is. Only look here, these are the two parts. Okay, in both the parts PR is there, so I'll take PR common. Okay, what remains? PS plus SR. This is from ninth step. So the, I think, second last step, what is there? PR into. What about this PS plus SR? Where it is? This is the PS plus SR. So what will get here? PR. Okay, this is from 10. Not only from 10, right? P dash S dash R. Like this one. Okay. Now the last step, just look here. PQ square plus QR square is equal to PR square. This is from 11th step. That is the proof of this theorem. Understand? Look, it is very, very important. This is Theorem of Pythagoras. Okay? Remember friends, not hard. What is that? Only apply this property. Choose two triangles. Which two? In which PQ should be there. So, write in the form of PQ square. Again, choose QR triangles. Write in this form by adding. We take that PR common. The remaining part is also PR. By multiplying, we get PR square. Okay? That PR is nothing but hypotenuse. Understand, friends? Now, students, we'll take now that next property, next theorem, which is Converse of Pythagoras. Converse means what we proved now, that is given, and what they given to us in previously, that one, that is we have to prove. Means what? The statement, look here. In a triangle, see, it is not right angle, only triangle. In a triangle, if the square of one of the side, which is equal to sum of squares of remaining two sides, then the triangle is right angle. Which one we have to prove here now? Okay, see first. Okay, again I repeat this one. In a triangle, square of one of the side, which is equal to sum of squares of remaining two sides, then the triangle is right angle. Okay, see here, the given triangle which is not right angle, which we have to prove right angle. So, look here, I will draw like a right angle, but I am not mention here right angle. Okay, see here, I will take here ABC. Okay, see given. What is given? In triangle ABC, what they are given to us? Square of one side. I will take this one. So, square of one side, which is equal to sum of squares of remaining two sides. It is given. So, we have to prove what? This is right angle. Means B should be 90. We have to prove. Okay? Means angle ABC equal to 90. That is our aim. Okay? But here we are going to say, make some construction. That is just different. See here, we are going to draw one more triangle here. One more triangle. I will take here as PQR. How will draw? In draw triangle PQR such that, look here, PQR, AB equal to PQ. Look here, AB equal to PQ. Okay, BC equal to QR. Okay, and extra part is that Q angle is 90 is now given. And then we'll join this PR. See, I'll repeat again construction. Draw triangle PQR such that AB equal to PQ, BC equal to QR, and this Q is 90. Join PR like this. This is our construction. So I'll write this construction here. Draw triangle PQR such that AB is equal to PQ, BC is equal to QR, angle Q equal to 90. This is the way. Okay, we can draw now. Take AB with PQ, BC with QR. This angle which is 90 is extra. Okay, like this one. Now look here. I'll write the constructed part first. Okay, constructed part first. See here. What is that? In triangle PQR. What is that? Angle PQR equal to 90. AB equal to PQ. Okay, friends. And BC equal to QR. This is construction. Because of this, the triangle PQR becomes what? Right angle. So we may apply Pythagoras here. So right now PR square is equal to PQ square plus QR square. This is from 1 and by Pythagoras. Okay friends, now I'll replace this PQ means what? AB square. This QR means what? BC square. I'll just replace. This is from 1 and 2. Just look here. Okay. Now just observe here the third step. PR square is equal to AB square plus BC square. It is very similar as like in given part. So I'll write here, but AC square is equal to AB square plus BC square. It is given. Okay. Observe here. It is like this one, but they are given to us like this one. Means their one side is same. Means we can take the second side is same. So PR square equal to AC square. PR square AC square. I'll take just PR and AC. Both these are same. So PR equal to AC. This is from third and fourth. Okay. This AC and PR both becomes, now they become same. So, in the two triangles ABC and PQR, see here, this equal to this equal to this, now this equal to this. Means by SSS test, these two triangles become similar. Sorry, not similar, they are congruent. Okay, see first. AB is equal to PQ. BC is equal to QR. This is construction. Okay, and here AC equal to PR. This is from 5. Therefore, these two triangles becomes congruent. Yes, take the names ABC, PQR like this one. Okay, this is by SSS test. Okay, now once the two triangles are congruent, we can take their remaining conditions are automatically satisfied. Which condition we have to take remaining one? See here, what we have to prove? B is 90. So I take angle B to angle Q. Both these are congruent. Why? CACT. So angle ABC congruent to angle PQR. This is by corresponding angle of congruent triangles. But what we know, PQ are equal to 90 from 1, or you may write construction. Okay, therefore the last step becomes angle ABC equal to 90. This is from 9th and 10th step. Understand, friends? Like this angle becomes 90. This is the way to prove this Converse of Pythagoras theorem. Yes?